nuclear fusion. We have nuclear fission and nuclear fusion, and they can be a little confusing. Fusion is the combination of two things fusing together. Fission is the other one, which is splitting apart. So in nuclear fusion, we have two nuclei combining together to make one heavier one, whereas nuclear fission is the splitting of a big nucleus to make smaller ones. Both of these are highly exothermic because the daughter nuclides have greater binding energy per nucleon than the parents did. Fusion is the energy source of the stars, including our sun, and it's also the basis of the hydrogen bomb. The hydrogen bomb is not a fission reaction. So the hydrogen bomb is much more violent. I'll just read the stupid words. The hydrogen bomb has up to 1,000 times the explosive force of an atomic bomb. So these guys really, really destructive. So what's happening here is we have two different isotopes of hydrogen. Regular hydrogen has one proton and no neutrons, and that's called protium. This is called deuterium because it has a mass number of 2, because it has a proton and a neutron. And this is tritium, which has 2 neutrons and 1 proton, so the mass number is 3. So tritium and deuterium can combine in a fusion reaction. They make a helium-4 nucleus, an alpha particle, and they spit out a neutron. The way you start this reaction is with a small fission bomb. You need a bunch of energy to get this going. So you have a small fission bomb that you detonate, and that is the energy source that gets this one started, and then you get the big kaboom. So nuclear fusion would be really awesome as a power source. It's got 10 times higher energy density than fission. The products that are given off are less of a problem than the waste from a fusion power plant. The problem is that no physical material can withstand the temperatures that the fusion reaction generates. So that's kind of a problem. So of course, people are working on this, and we're getting closer, and hopefully someday this will be economically feasible. But this is the tokamak fusion reactor. And so here they're using magnetic fields to contain the reaction, because this happens at such a high temperature that you get a plasma, which is the 4th state of matter that we don't talk about in Gen Chem. So don't ask me, please.
So we can't talk about it?
Oh, you can talk about it, but this is about the only place it's mentioned. So any questions about fusion?